In this video, we are going to practice adding and subtracting rational expressions, which is really just adding and subtracting fractions. And when you're trying to add and subtract fractions, you need the denominators to match. And the same thing is true here. Since these denominators already match, I can go ahead and put them together by combining the like terms. So this will be my final answer. Let's try a few more problems. In this example, you can see that the denominators are already the same, which is good, but this time we're subtracting. And I just want to make note, you're not just subtracting the 3x, you're also subtracting the 1. So we just want to make sure our signs reflect it. So it ends up being 5x plus 2 minus 3x minus 1, everything over 6y. So just like all the other problems we work out, you always want to put like terms together. So 5x minus 3x is just 2x, and 2 minus 1 is just 1, and they have the same denominator already, so we can keep that the same. Next, we're going to do some where we have to actually change the denominator. So the same thing we used to do with regular fractions, we would find a common multiple and change the top and the bottom. We want to do the same thing here. When I look at 3x and 4, the common denominator that they both can be is 12x. So that means that the first fraction must have been multiplied by a 4 at the top and the bottom in order to get 12x down here. So my new numerator is going to become 8. And for the second one, the bottom needs to get multiplied by 3x to become 12x. So you just want to make sure you do the same thing at the top. Now the denominators match, and I can put these together. But something else that I noticed is that 3x and 8 are not like terms, so don't try to force them together, but we are going to write them as a sum. Let's try a few more where we have to find a common denominator. Notice they're not the same, but they are a monomial, meaning it's just one single term. So when it's a single term, it is a little easier. So looking at these fractions, I can see that the common denominator would be 2x to the 5th y. So basically, I just want to multiply the first fraction by whatever it's missing, and then I'll do the same thing with the second one. So the first one is missing a 2 and a y, so we want to make sure we do that at the top and the bottom. So that becomes 6y squared. And the second one is actually only missing x cubed to make them match. So that's going to become 5x cubed at the top. So even though my denominators do match now, just like the previous example, the numerators are not like terms. But I am going to just rewrite them as the difference because we are subtracting. And this will be my final answer here. I'm going to do something similar again. I just really want to see what's missing from each fraction. So I know I'm going to need a 2, at least an x cubed, and at least a y to the 4th. So that's what the denominators need to become. And I'm going to check the original problem to see what they're missing. So this one's missing just an x, so that's going to become 3x. This one is missing a 2 and a y cubed, so that's what we're going to multiply at the top there. That becomes 14y cubed z. And just like the other ones, these numerators are not like terms, so don't overthink it. If they're not the same, you can't put them together. So don't even worry about it.